Welcome everyone to Silk Road Nexus Conversations. Today we are going to decode the intersection of AI, logistics, and automation. I'm joined by Shyam Krishna, Head of Integrations at Roboteon, a company building the brain behind the modern fulfillment centers. This conversation will help us understand the next wave of warehouse automation that goes beyond robots, revealing how AI driven orchestration layers will unify humans, machines, and data into a single intelligent network that is faster, more adaptable, and fundamentally reshapes how products move from shelf to doorstep. Let's begin this conversation with Shyam Krishna. Shyam, for joining us, and I'm pleased to have you. But before we get started and get into the details, I would like to learn about you, your journey, and also about Roboteon, how it was founded, what gaps did you see in the market, and that'll set the context. And from there on, we can jump onto the journey of orchestration and physical AI and integration to that particular world. So please introduce yourself to our guests.
Thank you, Nikhil, for having me. A pleasure to be on this podcast. As I said, I'm Shyam Krishna, I'm Head of Integration Services Roboteon. My journey into the supply chain world is fascinating. It was never meant to be 25 plus years back, but the founder CEO of Roboteon also happened to be my mentor, colleague, friend past. We and a bunch of my peers at that time who were also engineers who had a dream in terms of starting something in the supply chain area. This was in the mid-90s. We huddled together, and then 1999, officially the founder CEO of Roboteon started Softeon, which is a best-of-breed WMS company. So we just were a startup complete with very little background on supply chain and WMS, and then the journey had been incredible. We turned it around over the years to one of the best in breed WMS. For more than a decade, we were considered a visionary in the Gartner Magic Quadrant at that time. Then the founder CEO of Softeon started Roboteon 2022. So it's a combination of warehouse management systems background, implementations of very complex projects across different verticals, global expansion, and all the experience put into together to realize what is the next happening thing in terms of robotics and automation. It was always there, that especially the last 5+ years or so. But combining it with an explosion of AI, generative AI, starting with the ML first and then large language models, everything fell into place. The founder CEO of Roboteon, Anna Govind, spent 2 years building the platform for multi-agent orchestration, or in layman's terms, we can call it multi-vendor orchestration. We're going to talk more about it. And I was very, very thrilled to get into the next happening thing in supply chain, which is how can we bring people, automation, and robotics together to work seamlessly as one.
Awesome. And I think congratulations. First, I think 25 years is a long tenure in a particular industry. And I think you definitely classify as like a top expert with that kind of knowledge in your to be shared with everyone else as well. But I think one thing that you very promptly and aptly said is the next happening wave or the next happening thing in the supply chain is robotics and AI. To jump and kind of start talking about our topic today, which is on orchestration, physical AI, multi-agent orchestrations, etc. First thing I want to understand, how big is this thing? Like, is this a hype around this next big thing on physical AI in warehouse automation, etc.? Or is there a real need and a cause to deploy AI tools in such a manner that can increase the productivity of a warehouse team, of a company that owns multiple fulfillment centers? And if that is the case, then what exactly is an organization going to get out of all of the automation that we are talking about at the end of the day?
Absolutely. It's a fascinating question to begin with, because that's a logical thing to do. So the answer, short answer to it is, it's not a hype. Let me be emphatic about it. It seems like a hype for laymen and also even industry professionals who are like, what is AI going to do to me, or robotics, and what is it all about? Because I'm running my fulfillment centers, there's automation, automation for, existing automation which I'm running for the last 20 years or more, or maybe I'm just doing, RF-based operations with my standard WMS. It's a concept which people are struggling to grapple with. So the answer to it is, if you really look at enterprise systems for supply chain management, traditionally it would be systems, or what I call a system of records, from a perspective of ERP, enterprise resource planning, which obviously does planning at the enterprise level. Specific to supply chain, it plans inventory, order to cash, purchase to pay, etc. Then comes the fulfillment part, which is your WMS. It's a system of record. Then when we had traditional automation, like a decade or two, conveyors, weigh scales, and sorters and stuff, how does the WMS then communicate with these type of machines? Let me put it that way. But in a broad term, would be material handling equipment. Essentially, that would involve warehouse control systems, which speaks the language which the machinery understands, which means the equipment, material handling equipment understands. Everything, all what I described about, is all discrete tasks, right? I mean, you have electronic records in terms of inventory, in terms of, planning, allocation, etc. Those are all system of records. And then you had systems for handling the material. There is no bridge in today's world when it comes to robotics, because robotics is here to stay. It's the next best thing because it's driven by artificial intelligence, which is trying to mimic human intelligence. And so people are struggling to grapple with, why do I need AI and robotics to handle? So the answer is, you're dealing with, on one hand, a system of records, and then you also, on the other hand, you need a system of activity or system of motion, right? Because when it comes to robotics, it's all about being dynamic. The robot moves in a dynamic way, orchestrates, works with people, moves around people, and then fulfills certain tasks and aids humans in certain tasks. So this cannot be accomplished by traditional WMS systems. They cannot handle robotics in that way. And then the other side, the traditional material handling systems can only handle certain signals which will make them operate whatever they're supposed to operate, right? I mean, whether it's a sorter, a conveyor is supposed to convey, or a weigh scale is supposed to weigh. So what happened, to conclude, the answer is, so when you're talking about robotics are the next generation of technology which has AI embedded in them, and they fulfill certain things which no traditional MHE can do and no traditional enterprise systems can do. But there is no single glue to tie them all, right? So that is where the next generation of software for supply chain management comes in the form of orchestration systems. So the orchestration systems are a glue between tying up enterprise system of records to systems of action. The systems of action could be robotics, it could be traditional MHE, but putting it all together, that is the glue which is going to coordinate, orchestrate systems with all the technologies of the past and the future, and with humans, if that makes sense. And
It,
only AI can enable that.
no, it absolutely makes sense. It's basically acting as a systematic direction for robots to be able to act and play autonomously in a warehouse setting without the input from humans to actually control and guide where the robot should go next, what item to pick, where to place those items, and how to handle inbound and outbound.
A slightly beg to differ from the definition, because the human inputs are still there. As you know, Nikhil, I mean, you're a supply chain professional yourself, and in your day-to-day life, you are planning something. You are doing your upstream supply chain planning, and then you have so much available to promise inventory. You can plan your weekly demand, and then you are planning your tasks, etc. But the way you're going to execute it with robotics is the only thing which is going to be different. And the word, and in a way, I would say that the word autonomous is still a misused word, because there's now no such true thing as autonomous robots, because the robots have to be orchestrated. So in Roboteon, we always try to explain or even visualize it in a very simple way. I would like to bring that to tie it all up. And we did this in one of the largest trade shows recently in ProMat as well, right? So we had this nice visual where we had, because the word orchestration means obviously it's like a symphony, right? So if you, for a layman's perspective, you look at different robotic technologies as different instruments, right? Like a bunch of, celloists, a bunch of, violinists or piano, everything. These are instruments. And then there's a script to be played, right? But without a conductor, everybody group of these instruments play in perfect way, but it's chaos. Because when you put it all together, there's no symphony at all, right? So the conductor is really conducting and then makes that happen, right? So imagine the next generation of orchestration. That orchestration is basically conducting all of them seamlessly to work in harmony, right? So that means you have human operators in the warehouse. You have robots of different kind, different technologies, and then you have traditional automation, and then putting it all together is the next generation, next vision of the happening thing as far as technology is concerned. So that is why the word orchestration is becoming more meaningful when it comes to robotics, if that makes sense.
It absolutely does. And I think I have a few more questions related to this. But what I will do is I will pause on one of those questions because I'll hit on it in the next section that we'll talk about. But before I go into the next section, from a business perspective, if I have a business and I own a fulfillment center, what is an advantage that I get through an AI-enabled orchestration system that is able to automate a lot of my processes? So as a business, what is the actual gain that can be talked about? From my perspective, when we look at supply chain, usually from a warehouse perspective, what I'm looking at is a throughput. Items come in, items go out. As long as we are able to meet the inbound strategy of being able to stage the items, place them in the right area. From the outbound perspective, if we are able to meet the cutoff times of the trucks, I think we are from an outside world who is not managing a warehouse, things seems to be okay. It's working fine. But if a business has to invest in it, what is the actual outcome they need to drive and work towards so that this becomes a successful strategy for them?
It's a complicated question. Let me break it down. You're absolutely right, because for somebody to think about investment into this next generation of technology, there has to be real decision drivers. And in a simplistic way, how I would think of it and how I would articulate it is, if you're looking at driving more efficiencies, more throughput in your warehouse, that concept itself has been evolved over 10 years, 20 years, etc. How, for example, I think you and I will remember, traditional ERC KPIs, for WMS work KPIs. So if you're measuring key performance indicators for your warehouse, then you would get this feeling that everything is perfect, or if it's not, then you know how to tune it. So you're always looking at picking accuracies. You're always looking at, dog to stock. You're always looking at, throughput, shipment accuracies, if I'm meeting, 100% accurate or 99.85.
Sigma concept, basically, yeah.
Yeah, exactly. But what happens is, now you have a bunch of performance indicators and you try to apply the same in your decision making when you're trying to think, okay, so I'm going to get these bunch of robots or robotic technologies. How is it going to improve? That is where the friction gets created, because there's no true understanding of, or it's still an evolving standard. There are no true, KPIs or measurement indices in a human, robotic, automated environment, particularly driven by AI, because you try to apply those over here and then you'd be like wondering, if I'm going to have I'm hitting every one of my KPIs, what the hell am I going to do, investing millions of dollars with this, right? But the challenge is different. Now what is happening is, as you're squeezing or you're pushing the envelope by making robots doing repetitive tasks which humans are doing, or robots doing most of the movement which humans are doing using traditional forklift trucks and walkie riders and things like that. The problem is, you have to measure the efficiencies by different standards, and then you're going to say that if I'm going to invest so many millions of dollars, how am I going to push the envelope to go much beyond my traditional goal? You bring in robots and then immediately there's a popular myth that the human resources go down, right? I mean, if you have 5 operators, you cannot, let go of 4 of them because you've got bots. That's a danger to your business, right? And it's not going to change anytime soon. In a conservative, as I'm a conservative thinker from the operations perspective, it's not going to, AI is not going to threaten any jobs anytime soon, because how can you let go of people thinking that everything is going to be running by itself? But the measurements are different, right? So which means you're talking about flow where, are you optimizing travel times of robots? Because the picking persons or a set of people in a hot area are doing the picking, and their efficiencies are still up to the mark, because going by the KPI, which I said, the pick rate, you're still meeting that traditional WMS KPI of 10 years. Then what happens if you're trying to bring in movement efficiencies by bringing in AMR fleets, and then they're now standing in line because the orchestration is absent. In the absence of true orchestration, then you're fulfilling one KPI, but somewhere you're missing your shipping SLA simply because of problems which you cannot grapple with. It can be an overstretched statement because, in a particular zone, a particular robot vendor would have fine-tuned it because they are running AI to run their bots, and then they would try to orchestrate it. But keeping in mind that the orchestration happens in that silo, any other extraneous factors happening in the warehouse, there could be multiple things which can go wrong at the same time. They don't care, right? But ultimately, the KPI of what is the workflow throughput or efficiency in this new environment, new paradigm of humans and bots working together, has to be truly measured. And that's where, as a company, we do have these simulation platforms and production digital twins, and we're going to dive deeper into it, which gives you that perspective of saying that, yes, you invest in this particular area and with this combination of humans and bots, and then you're going to get a certain gain, which traditionally you weren't. Also, final thought to it is the whole life of warehouse fulfillment centers and managers and supervisors and operators of these FCs, right? They are, in spite of all the current automation and no matter whatever WMS they have, let's say it's the latest and greatest, best of breed. So it's not about casting aspirations of WMS. In spite of everything, right? The events and day-to-day problems which they face, there are no dynamic reactive mechanisms, because a human can only think that much, right? So I'm a wave planner. I've lots of waves. I'm thinking that it's running fine, but normally it does. But in one particular day or week, it's a very abnormal peak season. 20 things are going wrong, and then I miss certain KPIs. So the way AI is going to look at is AI is not only going to handle telemetry and dynamism to movements of robots and vehicles. It's also going to look at so many other events, which exceptions which are happening in the floor, and then keep reporting into the system of record. So WMS will know that it's so quick in terms of telling what's wrong, and so that the people who, a wave planner or who's sitting in a traditional WMS world is now going to be fed a lot more inputs on exceptions, because AI is managing it, and also it's going to feed inputs from different telemetry data of different vehicles moving, and then it's going to say that with this current state you're off SLA or you're on SLA, and then through constant self-learning, it's going to get better and better, and then advise. What is the value you place to that? That's not measurable in current day WCS systems, which can still drive a robot and then optimize it, or individual vendors who have similar software, but they can do it only where they're designated to do. But nobody is looking at orchestration, like to go back to the symphony and the conductor analogy. There's nothing which can do and give you those are the indicators and data and metric which is going to push the envelope of efficiencies and throughput in the new paradigm of humans and bots working together. That's where the family of orchestration software like we have is accomplishing that.
Sham, I think what you have described really makes sense. But from where I'm coming, and when I talk to a lot of these players, there seems to be a lot of confusion between different terminologies and how do we interpret them. For example, there is WMS, there is WES, there is MES, and then there is orchestration. How does
someone in that particular arena try to understand these terms, make meaning out of it, and decide what is going to happen in the future and what is happening right now.
Yep. Thanks, Nikhil. I mean, that's important to tee up our discussion, the deeper discussion into multi-agent orchestration systems, because we have to understand basic definitions, which is confusing everybody in the industry. So, at the very minimum, everybody knows ERP, enterprise resource planning, warehouse management system, which governs the warehouse operations, inventory logic, and tasks, fulfillment, package ship. When it comes to WES, warehouse execution systems were the first orchestration systems. They are orchestration systems. And I would be totally out of thing if I say that MAO is different from WES. But MAO is where WES wants to be or will be in the next couple of years. What do I mean by that? Warehouse execution systems are like a decade in maturity, decade plus. The individual WMS vendors, best of breed, or even the ERP/WMS vendors like SAP and Oracle, they all have execution systems like SAP has MFS, or they could be best of breed having their own WES. And WES systems are still rules based, and you have different platforms. You could have different rules engines based on whether it's a Java stack or any other stack, technology stack. So you can define rules and then implement the rules, and behind the scenes, it's going to be executing database procedures or trigger tasks or sequels. So ultimately, this is, while you can say it's event driven, it can handle events which are published to it, and then it can recognize and respond to it. It can also orchestrate, but it's discrete, because every time you want to change a business rule to a warehouse execution system, you have to change the rules. The configurations are still a decade old, right? And the last point is on the WES is it's not really platformed or retooled to make it fully agentic. People are trying to get into that. That's what I meant by my definition of commodity software. Orchestration systems will become commodity down the road, because companies are investing into AI enablement, and then look at agents trying to handle the orchestration. So invariably, they'll morph themselves into MAO. Now coming to WCS, that's the traditional lowest layer which communicates to the PLCs, right? Warehouse control systems communicates to material handling systems, which are, again, they have their controllers, and the PLC controllers are, very simple data structures, and you exchange signals back and forth, look at the health of a connection, etc. So WES in turn can communicate with WCS. That remains, because traditional automation, traditional systems which are driven by PLCs and other controllers are still going to remain. So that is your lowest level. MES is a larger concept in the manufacturing world as opposed to warehouse. MES is manufacturing execution systems, where you could have automated production lines, where it can be a bottling plant which is just producing 40 million case equivalents of a particular soft drink, which means every shift, thousands of units of product comes off the production line. So when you're orchestrating a number of things, right? If it's beverage, then it's continuous process. At the end of the line, you take the pallet, and then you recognize it from an MES signal. So that's again a protocol. It could be REST, it could be sockets, or it could be any other standardized protocol for MES systems, where you take that and then decide, yep, I have so much of this particular batch of production. What do I do with it? Do I put it in the finished goods warehouse, or do I stage it? Or if it's a discrete manufacturing system like automotive, you have MES systems where it will do sub-assemblies and then hand it off to the next work center, and finally you'll have a portion of the automobile put in the warehouse, and then another vendor would send the engines, and then everything gets assembled. So MES is a different family of software, but again, the principles are you take signals, you orchestrate it. So in summary, you have the ERPs, the WMS as system of records. WES, I talked about it as the first generation of orchestration systems. and WES in turn goes to a low level of WCS to communicate with PLCs and controllers. MES is purely manufacturing execution systems where whether it's discrete or continuous process manufacturing, you take the signals and then you orchestrate the movement of either fully finished or semi-finished goods into work centers or into component or fully finished warehouses. So that's the definition.
Got it. And I think that's a very fair point because I think, as you mentioned, there is actually today a gap where we don't know what our next best is going to be. And I think that's
Exactly.
the problem with establishing benchmarks for these new autonomous or
Yeah.
orchestration systems because we don't know how far we can go up and
Yes.
increase our level of efficiencies. So
And,
that's
and one and one simpler point there, which I wanted to make is, you take traditional WMS KPIs, which you've been so used to, and everybody in the warehouse is used to, and then try and then measure, robotic throughputs and combination of robots and humans working together. It's going to create friction. People be like, what is the robot going to do to me? I'm finishing my pick, and then still, I have a problem with the congestion among the robotic fleets. Or, I'm in a slow moving zone and then I'm walking up and down, I'm managing 4 aisles because I can't have 10 people in a slow moving zone. But then I've finished it and then I have, 3 minutes wait time for a bot to come near, closest to where I am in that zone because I'm the only one who's managing 4 aisles, right? How do you measure? That's where the friction comes in terms of trying to look at efficiencies with traditional KPIs. And you need orchestration platforms which can give you that picture of traditional KPIs mixed with telemetric travel KPIs and then mixed with accuracies of picks and accuracies of robots doing the jobs themselves, because you're trying to put in a robot where you knowingly know that the robot is not going to provide much ROI. It's just a fancy investment which is going to go to the waste, right? These are the new KPIs which are evolving, and the orchestration platforms have the ability, because they're designed from ground up, recognize these and then translate it to human terms, which is the completely next generation compared to the ones we are all used to.
so basically at the end of the day, if someone has to make an investment, it has to be a very thoughtful and driven decision in terms of does it really make sense at this point in time? Do I have scale that can support or that requires support from robots or AMRs to be able to go to the next level? If you don't have, probably the investment at this point in time may not make sense to those particular vendors or operators.
Yep. Or it could be even parts of the fulfillment center, right? The idealistic thing is, if people decide that I want to do everything is magic. I mean, going back, if everybody reads about, which we can talk a little later, the mega operators like Amazon and things like that, and then you want to take a leaf out of out of that. It may not. So what works best for you is to make that thoughtful decision in terms of using tools which can help you help with that decision, to identify, even if I'm not going to get benefits for my fulfillment center as a whole, can I make a start somewhere in a particular zone or in a particular area or in a particular seasonality or product profiles or whatever, and then make a thoughtful decision.
Okay, so that absolutely makes sense, and that probably leads me to my next question because I think we have touched a little bit about what is orchestration. We have identified how it connects the traditional WMS ERP systems and bring them together from an automated standpoint. We have also talked about how this particular investment should be thought of and how it should be made. Next, what I want to learn more about, kind of leading from these previous sections and get into the MAOs, which is the multi-agent orchestration systems. How are these systems designed? What goes behind MAOs? And why are they the next upcoming technology?
Sure. Excellent question, because it's a logical follow through to it, right? So just to recap, so we talked with the musical metaphor of the orchestration. So now imagine a software layer now trying to do the orchestration. And so how does the orchestration work? So again, I'm going to go to most misused word in AI, right? Everybody will be like AI. Some people say Gen AI. Some people will be like, LLMs and so on. And RAG, RAG. I mean, LinkedIn and internet is
Is
full of this jargon, right?
every day we hear a new shortcut and a new
You
metaphor for AI.
acronym. So just cast it away. At the very least, right? Uh, when you're talking about evolution, right? Machine learning was a foundation, right? Machine learning always had the ability to recognize data patterns in a world of unstructured data. I mean, we have to look at it that way, and then I'll evolve it into where MAO comes. I mean, all of us we were in an ERP and WMS world, right? For example, there were days where you'll get, if you have 100 vendors, you would get 60 vendors sending you ASNs, right? So there's the electronic form, and then you're so comfortable getting a 56, and then you're receiving, boom, your receiving accuracy goes up like that. Then the 20% is like, I don't have the capability of ASN, but my truck is going to show up at your door, and then you're going to and give you a bunch of papers, bill of lading, whatever it is, right? So there is a mix of unstructured data, and then there's a mix of structured data. So when you're trying to aggregate and build uniformity, that is the foundation, right? Machine learning would be able to take that, and then which means immediately you're looking at just your receiving process. You're going to be very accurately informed over a period of time that how your receiving is happening, and how is your vendor performances, how is your inbound quality from each vendor is, your vendor scorecarding. I'm just using receiving as an example. Imagine taking data patterns and then data structures in an unstructured world where you have some structured data in the form of electronic records, database records, etc., and then documents. So when you tie it all together and then try to get patterns, that's where the machine learning starts. But then when the LLMs started evolving, the LLMs would use these and then try to apply intelligence to it. And then the intelligence often at times is only as good as the data you're feeding and training, right? Because unless you do prompt engineering and training, it's going to be a miserable failure to start with. It's not like ChatGPT where you type a question and then it spits out. It takes years of OpenAI foundation, and then now you have everything, right? So the same way, think of it in a supply chain world where you have a learning agent which is now prompted enough to recognize certain behavior. That behavior could be like, I'm looking at order profile. I'm looking at resources. How many people are showing up in today's shift, and how many of them are cherry pickers or receivers or walkie riders, so profiled with their resources. So there is that. So you could have agents trying to look at human resources capacities, and then try to see with this human workforce, which is scheduled for today's shift or afternoon shift or evening shift, whatever it is, can I meet my SLAs? Then you have another agent, because it's a different thing, right? Where it's looking at demand. What is the ERP feeding to the WMS, right? So it's going to be feeding a bunch of outbound orders to be fulfilled. But the outbound orders, again, there's a complexity. ERP knows that, for these orders, for these customers, I'm hard allocating. Or I could soft allocate and then have my WMS decide, yeah, you can have a soft allocation, but then if there's an urgent order, then I can use some of the soft allocation and divert it to the urgent orders. But for certain hard allocated orders, no, it has to go. And then, whether your humans are going with the forklift trucks or robots are going, then, you still have to go and then finish the pick. So there's a whole process where you train the AI to understand demand, predict demands, look at volatility of demands. So that may be another agent. So when you're putting it all together, that is not the job of a robotics vendor to look at multiple things happening. There's a predictive analysis and demand for forecasting agents. Then there are inventory optimizing agents, days of supply, how I can take it, or if my ERP is feeding me, how can I use that aggregation of ERP over the next 3 months historical data or 6 months historical data, and then predict patterns. That's a different agent. Then comes the fulfillment agents, right? You have a fleet of AGVs from brand A, which is going to be picking full pallets and then dropping it off at put away points or ASRS drop away points. Or you could have AMRs who are moving about trying to replenish forward pick locations or doing the outbound fulfillment. There will be agents which need to orchestrate, because each brand would only work in their silos. So who's the conductor? Today's absence of a orchestrating software, there's nothing. So if you take all of these sample agents I'm talking about, put it all together, that's MAO, multi-agent orchestration. So which means these are a family of software where you're not looking at one particular function or a specific area. You're taking building different agents, and the agentic architecture and the platform is built from ground up, and then they work in tandem with each other, work together, and then it's also constantly understanding the dynamism involved. How do I route the robots because of telemetry capability of the robot? It can go around, it can go in this intersection, and brand B is coming. Do I pause and give priority to brand B? That's a traffic cop mechanism. So there are AI enablement from the individual vendors, a component of the multi-agent orchestration software. Putting it all together is MAO. It's a very abstract concept, but if you break it down into these examples, then people recognize, I need this, without this, then I'm going to be,
Manually
operating in
operating.
silos. And then I still have a system of records of WMS and ERP, which we need, we be sending completions, but they're not timely, they're not dynamic. What is the actionable decision if they can take if there's no orchestration? That's where the MAO comes into the picture.
Sure. And I think I have actually three questions from this particular answer that you provided. Let me start with the first one. One is, you said data is so important. Without data, we will not be able to train the models. We will not be able to achieve the outputs we want to achieve. From my experience, and agree with me if you have the same thoughts, but supply chain data is a mess. We don't have good supply chain data. We don't know a lot of things that happen in the fulfillment centers or the warehouses. They're not recorded. They are not there on the system of record. How do you think this particular gap that exists today of very unstructured data available or no data available going to be a problem, or how is that gap going to be closed? Because you need that data.
Very important question, and I'll be very careful in answering because I wouldn't want to show partiality to specific brands of ERP or large companies. I would leave it at that. The real leaders, I'll leave it at that, who are trying to approach bringing a unified data model in this unstructured world of data madness, right? Because the key thing, there are several components to it. There's MDM, right? So there's always a good MDM, no matter what, without belittling all what is happening in the last 2 decades. Every year, successful big corporations, even though there's, as you rightly pointed out, data is a mess in bits and pieces and pockets. There's always an MDM functionality MDM is an independent entity and not governed by IT. Sometimes, I've seen these, best practice people say MDM should be independent of IT because IT would say, can I get this fixed, master record fixed because this new item is coming? I have to get into my catalog and I have to get there'll be a truck to show tomorrow. Can you immediately fix it? No, MDM doesn't work that way, right? So there is an organized MDM function, due compliments to all the corporations who recognize successes in ERP. And then they have a big mess as well, right? They could maybe the class of items, consumables, and a lot of it where they can, non-batch manage.
I can give you one example that
Okay.
I face very difficulty with is dimensions. Dimensions are all over the place.
Absolutely, because ERP doesn't handle dimensions well, and WMS does a great job. You know why? Because WMS needs dimensions because you need to slot it into a particular rack location, or if it's floor space, or if it's a block stock, can I do 3 high from floor, whatever it is. ERP doesn't need it, and also the multiple units of measure, right? For picking unit of measure, it's different from an inventory unit of measure, right? So ERP can get crazy sometimes. Yes, there are good ERPs will have multiple units of measure, but you're exactly on point. Now, coming to the unstructured data, this is the data I talked about, right? Where you get so many things even today on paper or electronic documents, PDFs, and so on and so forth. And there's a whole bunch of data which you're not unifying into a data model. So that has become a AI field itself. There are popular data unifying platform using AI models, and there are companies, I have to be agnostic about it again, which enables to bring a very unified data structure for decision making. And recent conferences of all the big ERP giants who are embracing AI also talk about this. They in their keynote speakers sessions in every place I've been following, or talk about how do we bring unified data models, which ultimately trickles up all the way to the decision making of chief revenue officers or chief human resource officers or chief supply chain officers. Everybody needs to see that unified data structure. Now, having said that, now let's come down to our specifics in terms of our robotics fulfillment. So if we have a similar data structured model, so then what happens for us, our life is become very accurate, which means whatever predictive analysis we do using any AI model, right? Because there are different AI models for different purposes, right? For demand forecasting, yeah, you can build an AI model. For inventory optimization, you can build an AI model. Combining all these models is ultimately your platform, which does all these things, which I talked about, right? Which is what we at Roboteon is that once I rely on it and my model gets more accurate. So what I'm trying to do is if I get that data and then have my models try to learn and then it comes back with a higher degree of accuracy. So which means if I'm able to walk into a warehouse and the warehouse may not have robotics, but if I'm able to take data from them and then have my models learn and then come back and then if I can mimic their current operations to a level of 90% accuracy, then my baseline is established. That is a clean place to work on because it takes AI to learn. Because if you have a 50% accuracy, how do you start? Then you can't say, now give me a what if predictive scenario where if I introduce 5 bots, how is my throughput going to be? Throughput is the metric I'm going to talk about from a robotics perspective later. But if I don't have even that data or the baseline, then it's a mess, right? So the learning models have to be relying on structured data, and then platforms like us have to hit that accuracy before we then start doing simulations, optimization, predictive analysis to make the recommendations or scorecard scenarios saying, yeah, you're better off in this zone with 3 humans and 6 bots, and you're going to get a good payback, a return on investment in terms of these different set of KPIs. In somewhere else, no, you're not going to get it. Is the conclusion of your from my answer to your complicated question is how critical data is in terms of having to handle both structured data and unstructured data and historical data, and then use that to train your AI models such a way that you're ready to then make the investment decision. If you don't do that and you're relying on one particular zone, that's easy. All of us have done that. You know that, yeah, these are hot SKUs. There's so much up in the e-commerce market because of social media promotion. These particular set of CPG items, these pair of shoes or this clothing fashion line is going to be hot for the next 6 months, right? And I can 100% put robots and then improve efficiencies. Then what happens? I blindly go into the particular robotic vendor, work with them on a robotics as a service, and then try to get some quotes from 2 different or 3 different vendors, and then 3-year throughput annualized. Yeah, I'm going to make 40% savings or 30% savings. It only works in that particular area. Then what happens is if there's a change, order profiles changes, product preferences changes, even going back to your point, the packaging dimension changes, right? All your robotics orchestration has to be done again with that vendor. So it's chaos. So unless you plan and simulate and have your data and then have the models to predict demand, predict volatility in order profiles, predict how can we handle pick strategies given constantly changing or proliferating of SKUs, then it doesn't make sense to invest in and get locked into one particular robotic strategy millions down the drain.
And I think going by that same point, and I think this was also my second question from your previous answer, but I think you kind of touched on that as well, which is this has to be a specific strategy.
Yes.
Does this mean that for orchestration vendors like Roboteon or someone else like Locus who is building robots and is also offering Locus One as a service, Amazon, for example, is it going to become a commodity business where you have a set of software and orchestration layer that can be generic enough to be applied to different kinds of vendors in different kinds of scenarios? Or is it going to be a very niche specific business where you work with specific vendors, you start training those models again based on those scenarios, new scenarios, adverse scenarios for those particular situations? So is it a commodity business or is it going to be very niche specific business?
I think I would lean more towards the former. When I say I wouldn't use the word commodity, but it can resemble the next family of orchestration software. Now, I got to be careful in qualifying this. Now, can the orchestration software themselves be built by the best-in-class WMS vendors? Answer is yes, technically. Why? They're WMS people. We were WMS people, right? Before we built the orchestration platform. Now, what does it take? So the question is, the WMS vendors have millions of lines of code and functionality built over years across different verticals, and then millions of different versions, 10 versions, 5 versions, starting with the legacy, AS400 based systems, moving on to, Linux based systems, and then now moving on to full open architecture, cloud based, microservices architecture. So again, they have hundreds and thousands of clients. Now the question is, are they going to be looking into building these family of orchestration commodity software? Let's use the word for now. What does it take? Because that involves creating an ecosystem of not only taking functionality from the ERP and the WMS, but then you also have to take into account of telemetry and navigational protocols and communications of the individual robotic technologies. And then finally, how do you coexist with existing MHE, which are all more strict data structures, which can do a conveyor divert or light up a put wall. So putting it all together would be a big retooling of systems. And are they doing it? Highly likely, yes. Do you see them coming out with the orchestration platforms? Highly likely, yes. But currently, we are in a long tail kind of model systems where there are small vendors who are trying to build pre-built connectors. So there's a cautionary tale here, right? So when I say small tail, because you would have a proliferation of companies who would say, I have pre-built connectors to, let's say, dozens of robots. But they're not companies who have deep domain knowledge, deep operational expertise. That's not their job too, right? So as long as they do it, then they would say, use my platform, these 50 different types of robots, right? But yeah.
But one question over there is like, when we look at WMS became a commodity after a certain period of time because it was a software that worked based on inputs that were coming from the warehouse, for example, like how many items did I store back into the inventory, scans from boxes coming in, going out, and all of that data got collected. At the end, you can make a commodity out of it because it's all nothing but just data moving between the pipelines. But when it comes to what you were describing earlier about the orchestration layer, then it becomes a niche because if I take an example of, let's say, a Gap warehouse and a Target warehouse, a Gap warehouse mostly will be dealing with apparels. So they would probably be bulk boxes or pallets of apparels. And Target would have different kinds of items altogether. They could have furniture, they could have apparels, they could have groceries, etc. Now, these two become specific niches. For a WMS, I don't think it makes a difference to segregate between a Gap and a Target, but for orchestration, I think it would make sense to segregate them.
Yeah, I think you have a valid point, in terms of presenting the nuances of these two examples. One is an apparel giant, another is a CPG giant, right? So I don't know the specifics of what systems they use. So keeping it neutral, what I would say is, when it comes to WMS, orchestrating, apparel and footwear, pick strategies, etc., are different than when you're coming to CPG items, which you go to a traditional supermarket or a regular chain store, right? So we have different, product configurations. You have each picks, case picks, or sometimes if you go to a bulk store like Costco, then you can pick bulk items. So when it comes to, filling up the store stock, the big strategies would be much different for CPG. So orchestration platforms also have to cater to that. So in a way, yes, the orchestrations are still in niche because when these companies, no matter what WMSs they have or what WES they have, they are orchestrating as, using these niche products. They might have the WES product of the WMS vendor they chose and operate, or they could have best of breed WES systems, right? There are still industry agnostic WES systems out there which can drive a ASRS or a toad to person or goods to person systems. So everything is niche. Now compounded with that is, let's say if these folks are farming out a portion of their business to 3PLs, and 3PLs will have their own WMS, and they might have some automation or no automation, just RF operations. And then, those are again small niche systems. Sometimes they would buy a bunch of bots. 3PLs are known for that, right? For a particular zone, for a particular account. Let's say they want to offer logistics services for the CPG. Use the word CPG, not the name. And this 3PL would say, oh, for them, I need to have a portion of my warehouse automated because of the volumes I'm going to get from them, right? So if sales orders for me to pick and ship. So which means I could just buy a particular band of AMR and hard integrate. So there's no MAO, and then there are these niche pieces of software. So to summarize, what I would say is that the best of breed WMS vendors or ERP vendors who have their own WMS modules like SAP, Oracle, etc. All of them are trying to go towards a world of MAO, some through partners like us, some through building their own MAO products. So at that point, a few years from now, based on the hype cycle, they become commodity products. Currently, there's a whole bunch of niche products out there. But in terms of true MAO and combining WMS expertise, WES expertise, domain, etc., which we claim to be, and we are, based on our experience and evolution of our 25 plus years of experience. So we are kind of taking that step ahead, and we are like a few years ahead, and in the position where while we are niche, we have a mature, stable platform. But even though we're saying we're niche, there are very few players like us in this space. And my personal sense is, and full disclosure, it's my personal opinion that there could be smaller sister companies which could be kind of bought up, swallowed, or just go out of business. And then the real niche players who've got a stable platform and the expertise in the client base to go with it will be operating. And in the meantime, you would find situations where the WMS people who have the whole suite of WES as well are trying to very aggressively convert their systems into MAO systems. So that's the difference between how these larger entities are going to get into making MAO systems as commodity software. But the current state of how these are operating as niche is something I just thought I can explain, if that makes sense.
And I think that would be super helpful because when that hype actually strikes,
Yes.
you have an actual platform that can connect or provide that orchestration with multi-vendor scenarios directly to the fulfillment centers or warehouses at that point in time.
Exactly. If that
Makes
makes
sense.
sense.
Yes. And one other question that I had coming probably last on this particular segment of orchestration and technology, which is around the fact of digital twins. I know orchestration layer itself doesn't require a creation of a digital twin or a model of a warehouse to be able to understand or orchestrate things. It's probably going to be a robotics vendor kind of a thing where they need to understand the layout so that they can design the robots in such a way that they do not collide with each other. They understand and respect the boundaries between a human and a robot. But from an orchestration standpoint, is that availability of a digital twin going to play a big role? Will it help you in any sense?
Absolutely, and it's one of the key things which we can probably say, because what we do, given all that I've started off from the beginning of the podcast to where we are now, we talked about data structures, started about enterprise systems, and then we talked about robotic systems. So to orchestrate it, how do we orchestrate? We cannot orchestrate it with 1 day of data or a few thousand transactions and say, oh, everything is nice. Let's put this to production or let's put this to a UAT test. So when we're talking about digital twin, the key aspect for orchestration platforms is not only will it help, like I pointed out in my earlier example to your earlier question, is to look at different data patterns, right? Historical data, unstructured data, ERP data, and then try to make sense of it all, and then do the predictive analysis of what are the best investment strategies for robotics, what is the best throughput strategy, throughput KPIs, where would you be able to get ROI, how do you measure the ROI, etc., etc. You have to create that digital twin, and then when you're running these AI-based simulations and scenarios and have its scorecard, and then the decision makers at the C level, or even, it goes bottom up, right? The planners would look at the scorecards and then see what they like best, and then different, I like this model better in low season. I like this predictions of these sets of KPIs for mid-season, or not low, but somewhere in between, and then finally for peak season, right? And then they come back and then say, if we invest on X number of AGVs, or if we invest in, 3 or 4 robotic trucks, and then start with a certain set of AMRs, this is our scalability and this is our 2 to 5 year roadmap. That needs a digital twin, number one. Number two, that also becomes ongoing. So when I'm sure, we're going to be talking further into the podcast about that. When you're doing day-to-day work, you're better off doing something with a digital twin. Tweak your wave planning, tweak your traffic patterns, tweak your tasks, which is being pulled from an SAP or Oracle or whatever be the software, and then you're tweaking it and then orchestrating it dynamically. You don't want to be touching production unless you're sure that your digital twin gives you your best scorecarding, and then you can flip it the pattern. And then every day it's also going to learn by itself. At the end of the day, there's going to be aggregations of not only data, pick statistics and history and other replenishments and all the activity cycle counts, everything which is being fed back, but you're also getting events. What happened today with respect to congestion on the conveyor or sorter, or AMRs getting stuck? Everything, there's a cause and effect, which is again going back into a learning system. So you need a digital twin. But the final caution is, this is a lot of data. Then the question of ownership and source of truth comes in, where I will address it in a different question. I don't know if we're going to talk about cyber security and compliance, because this is going to trigger a whole set of compliances when it comes to AI and orchestration, where we have to say, what is an orchestration platform entitled to in terms of anonymizing data, running production simulation, etc. Ownership and stuff like that. I'll get into it if we are leading to that topic, but on the top of my mind, I think about that. But yes, the answer is production digital twin is a necessity, and that is how we are able to get good data, going back to our data accuracy and volumes and stuff of both structured and unstructured, and then that helps us in modeling. But then the other concerns I can set aside. This is the answer to your current question. We can dive into it if required on the aspects of compliance and ownership, etc. later.
Sure. No, I think that's fair. I think it really makes sense that digital twin information is available so that you are able to connect the dots of what actually happens on the floor when you provide an instruction, and kind of improve on those instructions as the models improve and kind of get better over time.
Exactly.
The another aspect I think is again, I think you mentioned about the data ownership part. That was probably my next jump from here. Is now we have the models, we have the capability to be able to apply these models and agents and connect different backend systems. But where does the data boundary lie? Now we have multiple operators kind of sharing the information. One is, let's say, a WMS party, which is still a free PWMS. There is an ERP, there is an orchestration team that is now handling the orchestration. Then there is an MDM, and then there is now also a robotics vendor that has come into the picture. Who owns what, and where does the ownership would lie? Like, is the warehouse owner now struggling to find the right party when something goes wrong? Or is it going to be easy enough to segregate and say, hey, if something goes off on the fleet side, it was probably not orchestration, but the robotics team.
Right.
Things like that. Yes.
Yeah, excellent question. So which brings right back at data ownership, which means we talk about data safety and also compliances, right? It's easy. It's not as concerning as it appears to be. To your question, it's a valid question. So let's set aside digital twin orchestration. Just set aside. Currently, how are these large corporations handling, let's say, an Amazon, UPS, FedEx kind of operation, right? Multi-client, huge logistics operators, global operators. Everywhere there is when I say everywhere, every campus of every region of every country, there is a set of compliances with respect to data management and data security, right? So, for example, there would be Canadian laws, or there would be GDPR laws, or there would be, even within the United States, California Consumer Privacy Act, etc. So, all these organizations, they have very clear boundaries with respect to handling data, not only from a data privacy perspective, consumer perspective, even B2B data perspective, what data and how it can be handled in production versus UAT or sandbox environments, etc. So that compliance still drives everything. And these folks, these big organizations are on the cloud, right? They could be on AWS cloud, they could be on Google Cloud or Azure or anything. So they can have their own private silos of server farms, all provisioned on cloud. It's not like fewer and fewer people are having their own data centers, right? So there is a certain set of compliances which are already in existence, ISO 27001 or SOC 1, SOC 2, everything. Now, the robotic vendors, they're already operating, right? Most of these big operators, they would have a bunch of robots, right? They could have a Fanuc or Yaskawa or Locus or Fetch or Otto or Mir or Omron, anything, right? So they have in production, right? They have the ability to send tasks to the robotic fleets which are in production. And so which means the vendor is in compliance with the information security policies of the customer. And it's already there, right? Now, the orchestration platform is also similar. The orchestration platform, like us, is going to be the tool of the customer, right? The customer is going to say, now I'm given the freedom and the liberty to synchronize, conduct, coordinate everything across different fleets and across different geographies, campuses. I'm unfettered, but I'm with this synchronization is also within my information policies security framework. What do I mean by that? So for me to take historical shipment data, all I need is just the data patterns, product profiles, unit of measures, and we can anonymize it. Or AI can look at the data patterns and generate a set of data for running simulations. So they're well within the boundaries of information security compliances, even as an orchestration platform which tries to use digital twin purely from an ownership perspective. So we don't own anything, we don't store anything. The cloud infrastructure where we have the multi-tenants but secure for that customer, which means I'll have a dirty tenant, or I'll have a let's say QA, and then if it's pharmaceutical, we have one more UAT, which is your GAMFI environment. So there'll be a fourth level. For production is finally the fourth level, right? So sometimes you have 3 levels, sometimes you have 4. But it's within the purview of the IT governance of that customer. So even when we are setting up these simulation platforms, we are going to be working within the boundaries of the compliance. And there's no ownership. And I'm sure same with other robotic technologies, because when they get a task, obviously a robot as a specific device of a particular vendor, it goes and picks a vial of or a carton of flu vaccines, right? So it has to be anonymized to the extent that it cannot expose PHI data, right? It knows a task, it has an anonymized thing, it'll pick, and then it'll stage it. Somewhere when the manifestation happens, the customer has pre-qualified HIPAA-compliant processes, and then they are going to ship it out. So translate that into retail or any other thing. Data governance, data ownership, everything would still rest with the customer. And for these digital twins and workbenches, we would have to comply with the data protection frameworks defined by the customers. So there's no multi-tenancy for these orchestration platforms as well, right? We don't host it and then say, look, you 1,000 customers, you just sign in and then we're not running a service. No, it has to be specific for a customer, if that explains, because it's very important, very, very important from a data ownership perspective.
Exactly. And I think the biggest problem comes in from a PHI and PII standpoint, because I know most of the data that we are talking about right now is, let's say, a company owned data, which is specific to them. But at times there are also PII data, which is like you're delivering to the customer. It's a last mile and you have addresses, phone numbers. You need to anonymize that so that you're not kind of.
To be a complete user group under fully HIPAA compliance, and they're annually tested for HIPAA compliance, or or even if there are robotic vendors, they have the annual user agreements which are set by HIPAA guidelines. Same with Europe and elsewhere, country-specific laws.
Makes sense. One last question on the overall business technology part of it. And I don't know if this is a right question or a very vague question, but it is definitely vague. What is an approximate timeline of a transformation of a project like this? Because I know it always depends on the size of the project, the kind of vendor or a warehouse that you're working with, or a partner that you have, how many robots they have. But in general, if you want to size this for me, like if I work with an X size of a warehouse which has, Y fleet available, this is how much time it's going to take to complete the transformation start to end.
Yeah, it's an interesting question. So, and I'll refer to the earlier question you talked about, is this going to become a commodity product or going to be a niche product? And I'll connect the dots from there. So, when we're talking about a commodity product, I mean, down the road, I mean, right now there are really very few players like us, right? But when you're talking about why, what it means as a commodity is the industry is driven by a certain common set of telemetry protocols. So we have the VDA 5050, we have ANT, we have ROS, or we have regular vendor-specific REST APIs exposed by the individual AMR vendors. The standards are still kind of not converging to a true 20-year plus scenario. It is still a fairly defined set of protocols and standards, right? So if we have a multi-agent orchestration, of which one particular agent framework is the ability for us to very quickly understand the API, telemetry, the navigational protocols of a specific standard, and that standard is being followed by 5 different types of, let's say, AGVs, or 20 different types of AMRs, then what happens is it's easy for us to be able to learn off their APIs. And for us, that's again the confidence, right? How accurate is it? So if I'm going to hit 80% accuracy in terms of how do I push a set of tasks to a brand A bot? It could be slightly different to a brand B bot or a brand C. Or how do I, make it release a tote when it drops off a tote, and then the tote has to be diverted to a place where the picking has to start for the next wave, right? So everything would be a set of typical functionality, but the ability for us to have this advanced platform where we'd be able to correlate very quickly and learn off the system gives the ability to going back to the implementation timeline. So if we are able to onboard a particular AMR type in a matter of hours or days, compared to the way I used to projects where, even in a 3PL environment, I have, let's say, a non-cold storage, non-cold chain therapeutics zone where I'm implementing an AMR, and then for me to even, to do a REST API testing, look at the data cleanliness, look at the JSON payloads, and then test it, and then move it to QA. And then after QA, move it to UAT, where we do the regular, if you look at GAM5 environments.
What you're basically describing is the same thing that I did in healthcare back in the day, where,
I'm coding.
healthcare.
You know how incredibly frustrating it is to do a operational qualification, a performance qualification, and then say installation qualification is ready. Now I can do a soft production launch.
Yeah,
It takes months.
it takes one.
Now, what happens is when you are learning one time for a family of particular AMRs, it's pre-validated. The adapters are pre-validated, and then the ability for us to do dynamic orchestration, that is configuration. You're not trying to change code. So either it's low code or no code, right? Mostly it's no code. Low code will be like the very rare exception where a customer comes back and then says, I want to make this workflow change. He could make the workflow change in an EWM or a Manhattan WMS or whatever it is, right? But if it comes to making a tweak to our orchestration, we can do that. But by and large, what happens is then the deployment timelines are compressed. So to answer the question, healthcare, I had to take it because that's a worst case scenario, right? So to answer the question, so the onboarding of robotic life cycles are very compressed. So we could very quickly, and also one of the important things, which I don't want to be getting ahead of myself, but one of the important things is If you scale the pilot, if you limit a pilot zone and then introduce, like, let's say, X number of bots, X can be like 3 bots, 5 bots, then scalability becomes very easy, because then you can put 100 bots of the same family, or test with, let's say you're walking to a brown field, there are 2 different types of AGVs and a couple of different brands of AMR or 2. Or maybe in one site, in one region, they have one particular brand, but then they say, oh, in Europe, we're using this. How can we have a unified orchestration platform? The answer is, define the pilot, make sure you test it, scaling becomes easy, and then the automation adoption cycles for robotics comes drastically down because of these orchestration platform compared with hard integrations. What I talked to you about using pharma as an example is a hard integration. Everything is a hard integration, right? So for example, or let's say even in a regular environment, with this I'll close, one more example, right? You're bringing in AGVs, full pallets from another manufacturing plant of, let's call it an automotive components, right? It's coming in, and then you're going to put it off into an ASRS, and then your assembly line, you need exactly for a given set of work orders, which are going to be assembled in 10 work centers, right? Those are smaller AMRs, which are going to take finished components, go to center 2, center 7, center 9. So when you're orchestrating this, just imagine that there are so many events which you'll be monitoring. How do you make sure that you give pause and then allow an AMR to go, give it priority, and then have the AGV, if there are intersections and different aisle geometries and things like that, right? So the point is, when you're implementing this, it becomes very easy to also virtually simulate. That's why the power of simulation not only goes back to predictive analysis and demand planning, etc. We can try out, like, I'm going to put 5 bots with in this assembly line, and then I have 2 AGVs. This is a 2 miles per hour speed of this particular vehicle, and this is a walking speed, and then see how it plays out, how the orchestration is, and then kind of do the simulation, and then gradually move to a regular control testing, and then do a scale testing. Also in the scale testing, because of the compression of some of this orchestration, as opposed to doing hard integrations and testing for every different vendor, we would have been doing AGV testing independently with that vendor, looking at their protocols, hard integrating that, and then with this AMR and with that AMR, it's enormous. That comes down. Then we can focus on messaging, right? Asynchronous, synchronous type of messaging, number of APIs handled per second. Do we throttle it, or do we not throttle it in real life scenario, right? You're dealing with a million messages, right? How do you handle that traffic, right? So those are governed by the middleware, right? It could be BTP for SAP, or it could be MuleSoft or Dell, Azure middleware. So any of these have all of these capabilities, so which means those are the kind of performance testing we can do before we scale up. So the adoption becomes a crucial thing. People will be struggling to integrate different technologies and then do all of this. But imagine you compress this and then focus on scaling up. And in that process, while you're scaling up, then you're also aggregating, and then these systems are learning off the test cycles. We run a full load cycle for 2 weeks, right? And then we're collecting data at the end of the day or end of the shift. And then we can fine tune waving upstream or planning upstream. A lot of productive things can be done rather than playing around with hard integration of robots. So that's where I see, when you ask the question about how much, I cannot quantify and say it's going to be 90 days.
No.
Or 120 days, but it will be significantly less. But a pilot, let me say, it will be very quick to realize that if you have a defined case for a pilot, very quickly we can adopt it. Very quickly we can have the pilot up and running and extrapolate from there that yes, it's giving the desired ROI, the goals that we set when we simulated initially, and then we can scale it up.
Makes sense. And I know initially I said this is a very vague question, and I know it'll be it'll have various answers depending on what scenario, the timeline we are talking about.
Progression is, crawl, walk, and run. So starting with the pilot, we can do the scaling up. But the onboarding of the robotic technology, that's the key. Learn off kind of MAO systems are learning off the orchestration of those different robots and other vehicles that quickly. That's the key. Because this is the next generation of software which is not available currently. traditional WCS and W.
One question before I jump into the future of what you see as like our closing thoughts. But one question, what is the biggest problem that you see when it comes to adoption of software in the warehouses? At the end of the day, I know it's connecting a bunch of back-end softwares, ERP, WMSs, etc. But at some point in time, the technology is also interacting with human workforce in the warehouse. Is there what kind of friction points, what kind of issues come up from that interaction of human and technology in the warehouse?
That's a very thoughtful question because there's going to be friction if, as a human, I am measured by the set of KPI which I'm already used to for the last 10, 15 years. Let's say every day I'm hitting picking accuracy because I know my job, I know my zone, and then I have, let's say I'm a senior level person, and then I have even juniors or even temps. But then I train them, I educate them, so I take pride in hitting my KPIs, right? Now I'm going to be working with robots, so somebody comes in and says, oh, there's this fancy orchestration platform and which is going to orchestrate workflows. The first thing for me is I have to participate in understanding how the workflows are going to work, right? That's a key. Then I'm not going to get frustrated, right? The most important thing is synchronizing the humans with the robotic workflows, right? Because what happens is if I'm doing my picks and then I'm waiting even for 3 minutes for a bot to come, right? That means due to no fault of mine, we're already picking up some latency right there. And then the bot comes and takes it. And, or another example would be, there is you're planning in this particular week, let's say this is a peak season this month. Same week last year, we have the historical data, and then because there's no proper planning and simulation, or we did some traditional simulation, Excel based, whatever it is, right? We are not anticipating dynamic changes because of social, because again, e-commerce, media, and whatever, online ordering, regular brick and mortar is dying. The point is, no matter what I predicted, I get completely a different set of order profile, 3 times the order volume. But let's say there are 10 particular SKUs which I can combine and pick. That means I'm going to take a significant portion of orders and fulfill it, right? That means even my batching algorithms, clustering algorithms have to be changed, and then it has to be recommended and then done. If we don't do it, then what happens is what we think as hot items, we'll have like 10 guys in one zone, and they're all clustered and picking something because of improper planning, and then bots are waiting. The end of it, the management is still going to say, hey, we missed certain shipping SLA, or we are off by, even 0.2%, because these days SLAs are very stringent. Sometimes you can be penalized or charged back.
And they also keep changing. Like, I know for a fact that, we measure some of the outbound folks specifically on how much they're picking and kind of moving. And at the same time, we also measure them accurate picking and accurate moving. Like, I want to prioritize order to move first, and then everything else follows. And they become very confusing for them. They're like,
Exactly.
how am I going to get my bonus?
The friction starts where they'll say that I'm doing my job, but the throughput somewhere something is getting congested. It's like a clogged drain, right? So the ability for orchestration systems is also to gather those events and self-correct. The self-correcting mechanism is where the power of AI works with orchestration, right? Because I have to scan and audit, or even if it's a regular scan, inline scanning, but the scanner has to asynchronously hit the gateway, and then there's some latency issues, right?
Yeah.
Everything gets piled up. But what happens, we analyze proactively, and then you look at that event and then say, don't send more cases. Don't send AMRs to that because it's all going to go to the hospital lane, right? What happens is then how do you measure a guy who's doing his picking, and how do you measure the AMRs, and then somewhere something goes out of control, right? So which means I think there has to be a metric or a set of metrics for robotic movements and robotic efficiencies, how they're effectively performing, how effectively picking is being performed by humans who are picking. Or if it's a robotic picking arm, which is again the final complexity, let's say you don't want humans and you invest much more in a collaborative robotic picking arm, right? So what is its efficiencies and what is its capabilities, right? You don't want it to get its throughput to be not to be measured. So we have to have a set of measurements so that the friction between humans and robots don't, robotic environments don't. How it does is the workflows which are orchestrated, we collect data and then we have these couple of dozen metrics as part of our platform where we'll be able to analyze everything cohesively and then see the throughput as a whole rather than just like the traditional WMS saying I got these 10 WMS KPIs, I'm meeting it, but wait a second, after all this investment we are still having links because of the bots.
That is.
We have to be very careful about it, and there'll be a lot of resistance if you don't have proper orchestration and orchestration platforms, and then you just individually, if you measure by silos, let's say if the particular brand works well, you'll hit every KPI.
Yeah,
Putting it together
yeah,
as a whole, no, it
yeah.
won't.
And I think the change management at that point becomes super, super important. Like,
Exactly.
and it has to be detailed enough to a level where you are not thinking, you're following a
Yes.
process.
And also in terms of how the education of the person who's going to not be scared of the bots, hey, I'm going to lose my job, or, it's no, I'm going to upskill myself, and which
Yeah,
is what Amazon is doing with that
e-
billion,
exactly.
whatever.
Defleet. Yes.
So it's upskilling so that how do they work, humans are working with robotic workflows, and how can they understand a different set of data analytics, data points and decision making compared to what they were used to 20 years back. I mean, you can see experience, I mean, in your own
Yeah.
warehouse you would see, right? People will just rattle off, everyday efficiency, orders picked, number of trucks loaded, number of routes shipped, accuracy. Today we had like, 5 short picks for 5 routes. They will have it in their head. But in this kind of paradigm, everything changes and then they'll be like, they're already threatened.
Awesome. Thank you so much, Shyam. This was fantastic. I know we recorded more than close to 2 hours today, but thank you so much. And I really appreciate your time and very good wishes for you and Roboteon in the future. So again, thank you.